Analyze phase. The analyze phase aims to sort through all the potential X that are causing defects. While taking into account all the X, the team has to concentrate on the few key X's that are causing costly defects. The team going through the analyze phase first breaks the problem into its vital few factors. During the analyze phase, the team members review the data that has been collected in order to make hypotheses that the team will test. Analyze phase activities. The analyze phase is a crucial phase. It can be broadly divided into two sub-phases, planning and execution. In the planning phase, the team quantifies the performance gap, identifies the vital X, and documents the benefits of improving the process. The team starts to write down the hypotheses. In its simple form, a hypothesis is a question. For instance, a hypothesis could state that by changing a setting from A to B, the number of defects would reduce by 25%. The objective is to prove or disprove the hypotheses. Typically in Six Sigma, the aim is to have a 95% confidence in one's answer. The planning phase ends by choosing the analysis tools. The execution phase begins with collecting the data. The next step is to perform the statistical tests based on the tools chosen. If the tests are significant, then the cost is moved to the improved phase. Analysis tool. Histograms. A histogram is used to graphically summarize and display the distribution of a process data set. It is also known as frequency plot chart. A histogram can be constructed by segmenting the range of the data into equal-sized bins, which are also called segments, or groups, or classes. A histogram can be created in Excel using 6 simple steps. 1. Enter data that you want to be in a histogram. 2. Click the Tools menu and select Data Analysis. If there is not a data analysis option under the Tools menu, you may need to install the add-on. 3. Click on Histogram to select the histogram option and click OK. Another window would open. 4. Select the input range, which should be your data. 5. Check the chart output box. 6. Click OK. Scatter plot. A scatter plot shows the relationship between two variables by displaying data points on two-dimensional graphs. It is the first step toward doing a correlation and regression analysis. It is used for investigating the influence of one factor over the output, or CTQ. The scatter plot can be made in Excel using 3 simple steps. Enter or copy-paste your data into an Excel worksheet. Highlight the columns that contain the data you want. To represent the scatter plot, open the Insert tab on Excel. Click on Scatter in the Chart selection to expand the chart option box. Select the first item, Scatter with only markers from this box. Analysis of variance, or ANOVA. Analysis of variance, or ANOVA method, aims to test the significant differences among two or more means by comparing variances. ANOVA is of 2 types, one-way and two-way. Using one-way ANOVA, the team can compare several groups of observations, all of which are independent but possibly with a different mean for each group. Two-way ANOVA is a way of studying the main effects of 2 factors separately and sometimes together, which is the effects of their interaction. ANOVA can be easily calculated in Excel. Example of ANOVA. In the Data Analysis window, scroll down and select ANOVA, single factor. Complete the ANOVA single factor window as follows. Enter $A, $2, $C, $7 in the input range box. Note that we have included the labels Group 1, Group 2, and Group 3 in the range of cells we selected. click the Columns button so that we indicate that our data is grouped by columns. Click the Labels in first row box so that we indicate we are using labels. For example, Group 1, Group 2, and Group 3. Enter 0.05 in the alpha box. Under Output Options, click the button for output range and enter $A, $9 in the output range box. Click OK. After we run the ANOVA in Excel, we get the following output. SS, or sum of squares, is the amount of variability in the data due to different sources. DF is the degrees of freedom associated with each SS. DF measures how much independent information is available to calculate SS. MS, or mean square, is an estimate of variance. F determines if the factors significantly impact the measurement. P is the p-value associated with F statistic. We have to check whether the p-value is greater or less than 0.05%. Quartiles. Quartiles are used to divide populations into groups. Quartiles can be calculated in Excel using the quartile function. Arguments of the quartile function are one array and two quart. Array is the array or cell range of numeric values for which you want the quartile value. Quart indicates which value to return. If quart equals 0, quartile returns to the minimum value of the array. If quart equals 1, quartile returns to the first quartile or 25th percentile value in the array. If quart equals 2, quartile returns to the median value or 50th percentile in the array. If quart equals 3, quartile returns to the third quartile or 75th percentile in the array. If quart equals 4, quartile returns to the maximum value in the array. If quartile is less than 0 or greater than 4, then the function returns an error. Hypothesis testing. Hypothesis testing is the central activity of the analyze phase. Hypotheses can be of two types: null hypotheses and alternate hypotheses. In a null hypothesis, there is an assumption that there is no difference in parameters for two or more populations, and that any observed difference in samples is due to chance or a sampling error. The team assumes the null hypothesis as true until it finds sufficient evidence contrary to it. The usual process of hypothesis testing consists of 4 steps. 1. Formulate the null hypotheses and the alternative hypotheses. 2. Identify test statistic that can be used to assess the truth or the null hypotheses. 3. Compute the p-value using Excel. 4. Compare the p-value to an acceptable significance value. If p is less than or equal to 0.05, that the observed effect is statistically significant, the null hypothesis is ruled out and the alternative hypothesis is valid. Outcome of hypothesis test. Alternate hypothesis is defined as hypotheses that differs from a given null hypothesis. Alternate hypothesis states that the observed difference or relationship between two populations is real and that it is not the result of chance or a sampling error. While a null hypothesis is a statement of no effect or no difference, an alternate hypothesis will state that a difference exists. In a hypothesis test, the team arrives at a decision based on the probability value or p-value for the given test. If the p-value is less than or equal to a predetermined level of significance called alpha level, then the team rejects the null hypothesis and accepts the alternate hypothesis. However, if the team finds that the p-value is greater than the alpha level, the null hypothesis is rejected. A hypothesis test can have 4 possible outcomes. These outcomes are whether the null hypothesis is true or false, and whether the team rejects or fails to reject the null hypothesis. In case the null hypothesis is true and the team rejects it, the team can be said to make a type 1 error. The probability of making a type 1 error is called alpha and is sometimes referred to as the level of significance. In case the null hypothesis is false and the team fails to reject it, it makes a type 2 error. The probability of making a type 2 error is called beta. Two-sample t-test. When the means of two groups are to be compared, where each group consists of subjects that are not related, then the Excel two-sample test procedure is used to perform these calculations. The hypotheses for the comparison of means from two independent groups are: null hypothesis is M1 equals M2, implying that the means of the two groups are equal. Alternate hypothesis M1 not equal to M2, implying that the means are not equal. Example data is given below. We will now perform the test. Example for t-test. The process of doing the t-test is Excel is similar for both the equal and unequal variances case. 1. Select Tools, Data Analysis, t-test, two-sample assuming unequal variances. 2. For the input range for variable 1, highlight the 7 values of score in group 1. For example, value from 20 to 27.5. For the input range for variable 2, highlight the 8 values of score in group 2. For example, values from 25 to 47.5. Leave the other items as their default selections. 3. Click OK. 4. The following output is created. Since the p-value is less than 0.05, this provides evidence to reject the null hypothesis of equal means. Reducing the gaps. In the next step, the team determines the ways to reduce or close the gap between the current performance and the potential for process improvement. The team begins with drawing a priority list of the opportunities for process improvement. The team identifies the problems that have to be resolved on a priority to achieve the maximum gains. Having arrived at the ways to resolve them, the team creates and evaluates alternatives in order to select the best options. In the next step, the team has to determine what potential problems and barriers could arise in implementing those best solutions. Having decided on the best solutions to improve the process and the ways in which any problem and obstacles on the course would be tackled, the team has to select the right people and appropriate resources that will be required to implement those solutions. Finally, the team translates the improvement opportunity into financial terms. Reviewing the project with a champion. Below are some of the questions that the black belt might discuss with the champion while discussing the analyze phase of the project. Did the team identify possible causes for variation in the targeted outputs? What were the conclusions been drawn from the hypotheses tests? Did the team then test those conclusions? Did the team use any statistical tests? If so, which one and for what purposes? Are there any important factors which need further investigation in the improved phase? Does the team understand the root causes of variation and verify them? Have the problem and goal statements have been updated to reflect the additional knowledge gained from the analyze phase? Have any additional benefits been identified that will result from closing almost all the gaps? Analyze phase gate review. We have arrived at the conclusion of the analyze phase. It is time now for the black belt to hold a phase gate review. The black belt represents a detailed report to the executive team on the status of the project. With reference to the report, the executive team may raise queries, make critical observations, discuss ways to overcome hurdles, allocate resources where needed, Provide reinforcement to the project team and ensure that the project is on the right course. Phase gate reviews are not technical. It is assumed that the black belt have worked out any technical problems. They are primarily to ensure that the project is proceeding according to the plan, that the team is meeting the deliverables by the milestones, and that the project is on time and within budget. Analyze deliverables. The analyze phase has several deliverables. It is not essential to prepare all of these. The black belt can take a decision in discussion with the champion and the team members. Some of the deliverables that can be prepared include metric graphs, details of major factors and root causes, analysis plan for proving or disproving hypotheses, hypothesis tests for various X as root causes, data collection techniques for hypothesis testing, leanings based on conclusion of hypothesis tests. Tips. During the analyze phase, the team evaluates potential X's that are causing costly defects. The black belt uses graphical tools to review and analyze the data collected and form hypotheses the team has to put to test. In the analyze phase, the basic tools used are histograms, scatter plots, regression, hypothesis testing, and analysis of variance or ANOVA. After determining the vital few X that are causing the greatest variations in the most significant Y, the team decides on the ways to improve the process to reduce or close the gap between the current performance and the potential performance. The team begins by drawing a priority list of opportunities to improve the process. Then, the team creates and evaluates alternatives and decides on the best solutions for process improvement. Next, the team finds out if there would be any problems and obstacles arising in implementing those solutions. Then, the team selects the right people and resources for improving the process. Finally, the team translates the improvement opportunity into financial terms. The analyze phase concludes with a review of the project between the black belt and the champion, and with the phase gate review. Module test. A hypothesis test can show the interaction of the factors A. True, B. False. Decisions in a hypothesis test are based on A. P-value, B. Beta risk, C. Alpha value, D. Beta value. Which of the following tools is not used in the analyze phase? A. Histogram, B. Scatter plot, C. Flowcharts, D. Regression. Assignment 1. The following is the score of two groups, A and B. Calculate ANOVA and also indicate whether you should accept or reject the null hypotheses. Assignment 2. Calculate t-test and also indicate whether you should accept or reject the null hypotheses. This is the end of our fourth module. Next module we are going to learn is Module 5, Six Sigma Improve Phase.